Okay, this is number 12. I'm probably not going to do the whole thing because you can check out the key if you want to see everything, but I am going to talk a little bit about the first part because I think we just need a reminder of Cauchy's bound and the rational root theorem and Descartes' rule of signs. So Cauchy's bound, please remember, Cauchy's bound, it's not necessarily the constant. It's not necessarily the constant over the leading coefficient. It is whatever number in here over the leading coefficient gives you the biggest number. So like you would do 9 divided by 3, you get a 3. 19 divided by 3, you get like a 6 point something or other. 57 divided by 3, you get a 19. 28 divided by 3, 28 divided by 3, sorry guys, I'm so sorry. 28 divided by 3, you get a 9-ish. And then 84 divided by 3, you get, what is that, 28? So what you do for Cauchy's bound, okay, so I'm going to write CB for Cauchy's bound. You're going to do the absolute value of whatever number over the leading coefficient gives you the biggest number, right? And then you add 1 to that number. So instead of 28, it's going to be 29. So my interval for my real roots would be a negative 29 to a positive 29. And guys, we got to remember that this was great stuff when we didn't have graphing calculators. Even though that's a big interval right there, that is a heck of a lot smaller than interval than negative infinity to a positive infinity. This was a really big thing before the invention of graphing calculators to help us actually solve these polynomial, find the zeros of these polynomials. This really did narrow down our search. Okay, rational root theorem, RRT. Remember, it is going to be the factors of the factors of the constant. Oh my goodness. One of these days I'm just going to hack up a lung. All right, factors of the constant. The factors of the constant are 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. And if you think that I just read those off the key that I was looking at, you are darn tootin' I did. And then you put that over the factors of the leading coefficients, so 1 and 3. Now remember, what you do is you take 1 over 1. That gives you a possible, oops, I'm like changing signs, pushing the wrong buttons for my pen. So you have a positive negative 1, could be a rational root. Then you take 1 over 3. So positive negative 1/3. I'm not going to write the positive negative again. Then you take 2 over 1. So it's positive negative 2. Then 2 over 3. Then 3 over 1. Then 3 over 3. Like you just basically take these, however many there are right there, I don't want to count them, red numbers, put them over the blue each time. You do not write your, anything that's a repeat, you're not going to write it. So you've got positive negative 1, positive negative 1/3, positive negative 2, positive negative 2/3, and again, I'm being lazy, and I'm leaving my positive negative out front, and then just writing all my numbers. I'll allow you to do the same thing. And then start with your 3. So you got 3 over 1. 3 over 3 is 1. 1 is already in our list, so I do not have to write it again. Then we've got 4 and 4/3. Then we have 6. 6 divided by 3 is 2. 2 is already on the list, so we don't write it again. Then we have 7 and 7/3. Then we'll have a 12. 12 divided by 3 is a 4. 4 is already on there. We're not going to write it. I got a 14. Then a 14 over 3. That 14 looks really weird. It's not there. There we go. A little bit better. Then I have a 21. 21 divided by 3 is a 7. 7's already on our list, so we don't write it. Then I got a 28 and a 28 divided by 3. And then I have a 42. 42 divided by 3 is 14. 14's on our list, so we don't write it. And then I have an 84. And 84 divided by 3 is 28, and 28's on our list, so we don't write it. So these right here are actually the possible rational roots. Okay, let me make this, hopefully I can make this a little small. Oops, oops, what are we doing? Trying to make this a little smaller, that a little smaller. Oh, it's all together. You know, explain everything, you're killing me. It's so random with how it, oh, see, look, do you, ugh. I'm trying to just move that, move that. Oh my goodness, that looked great. We're gonna leave it. We're gonna leave it. We're now gonna do Descartes' rule of signs, right? Descartes' rule of signs. Um, and actually, well, this is a really long video. I'm gonna stop this one and I'm gonna go and make Descartes' rule of signs with another video.